All right, good morning. Welcome back to trigonometry. We are going to talk about how to graph sine and cosine. Just go through the whole thing here. So I apologize. I usually teach this for the pre-calculus trigonometry, and we don't have a lot of time to go through things and kind of develop it in a way that really ought to be developed. So if I'm going too fast with this. The textbook has a lot of videos, which are now up, that kind of take you through this like one step at a time, rather than like the way that I like to do this, like kind of go through the whole thing. So the idea is what we're going to do is we're going to try to graph y is equal to sine x. We're going to go ahead and graph this. This is why radian measure was so important when we started this thing. So what I could start doing is coming up with some points to plot and just think about how that's going to work. So we can have here's my x, here's my y. And the x's are going to be in radian measure. They're just going to be numbers because we're going to wrap the number line around into a circle and then see how sine actually does this. So we're taking this circle and we're just going to roll this thing out like a number line. Okay, so just think like just gonna kind of roll this thing, I guess clockwise all the way through this thing. So if you like nail this kind of piece here to the origin, right, and then just kind of roll the circle out, that's kind of what we're doing here. So what I'm going to do is I'm going to say, well, we have x is 0. Okay, so 0 radians, the sine of 0 is 0. And then we have pi over 6, that's the smallest one. That's also 30 degrees, but we don't really deal with degrees on our number line. We deal with numbers. Excuse me, pi over 6 is out there. So that is going to be pi over 6. Sine pi over 6 is 1 over 2, or 0.5. Okay, and then we're going to go ahead and say, okay, 45 degrees, or pi over 4. That's a little bit bigger. We got square root of 2 over 2. Type that into a calculator. You got 0.7071. Okay, we have 60 degrees, and that's going to be pi over 3. Okay, and that's going to be the square root of 3 over 2, 0.8, sorry, 86, I believe. Okay, we have a calculator sitting up here, but we can go with that. Okay, and then we have pi over 2, and that's going to give us, sine is really measuring the vertical distance, and pi over 2, we have all the vertical distance. It's 1. Okay, we could keep going. Okay, we can just keep going around the circle. Okay, so we've gone on a circle. We've got pi over 6 is about here, pi over 4, pi over 3, pi over 2. And we are going through and labeling these out on our number line. The next one is going to be 2 pi over 3. Okay, we'll just keep going with that. So we have 2 pi over 3. The reference angle for 2 pi over 3 is 1 pi over 3. If I look back over here to 1 pi over 3, this was square root of 3 over 2, 0.8, I'm sorry, it's 866. 866 is what my thing is. Um, then we keep going on my circle. So we have 2 pi over 3 here. Again, second quadrant. Now we have 3 pi over 4. That's the next angle in line. Okay. So we have 3 pi over 4. The sine of 3 pi over a reference angle for 3 pi over 4 is 1 pi over 4. So that is square root of 2 over 2. Okay. And then we finally have pi over 6. Okay. 5 pi over 6. So we have 5 pi over 6. And that's going to be all the way up here with my circle. It's going to be down here a little bit. The reference angle for 5 pi over 6 is 1 pi over 6. There's 1 pi over 6 more needed in order to get to the horizontal. So the reference angle is 1 pi over 6. We go back up here. We look, okay, well, sine of 1 pi over 6, that goes back to being 1/2 or 0.5. Okay. And then we finally get to 6 pi over 6, or pi, right? Again, we're measuring vertical distances, and pi is on the axis. So that's going to give me a sine value of 0. You are welcome to check these in the calculators. One of the reasons I don't have students memorize all the reference angles is because you will always have your calculators with you. It'd be a good idea to start memorizing them so you kind of have an idea of how to do this. I'm going to talk, if we teach this face to face, I talk to you as if you've memorized these. However, I do not ever take your calculators away from you. You're always allowed to double check it. So don't be shy. Like I said, you're allowed to have a calculator. Use the calculator. Okay, so we're going to use that to kind of aid our intuition and figure out what's going on. Now, at pi over pi, or sorry, at pi, we are 180. We are back at we're back at the axis here. Now we're going to dip down. Okay, so we're going to go a little bit further. So we're going to end up with 7 pi over 6. Okay, the reference angle for 7 pi over 6 is 1 pi over 6. So I know that pi over 6 is going to look like a half, but now we've did it under the axis. My y value, right, for this angle, since we're over here, right, is going to be under the axis. My opposite side here is in the negative direction. It's going to be negative 1/2. Okay, so this is negative 1/2 or negative 0.5. And we can just keep going with this. Okay, so we're the next one we're going to say that's going to be so then we're going to have uh, 5 pi over 4 is the next one. Okay, and all I'm doing is I'm kind of doing this by telling time. Okay, I've got 1 pi over 4, 2 pi over 4, which reduces 3 pi over 4, but that's what we did. 4 pi over 4, better known as pi. That was it. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 5, 5 pi over 4. That's my next angle. I'm just counting in fourths around the circle. Okay. Again, we're in the third quadrant. The y value is negative, so we have negative square root of 2 over 2, or negative 0.707. Okay, and that's how we're going to keep doing this. We have 5 pi over 4. We are going to be able to say that we need, so we have 3 pi over 3, 4 pi over 3 is the next one. Okay, so we have 4 pi over 3. My reference angle for 4 pi over 3 is 1 pi over 3, right? If I do 4 pi over 3, it's going to be here, right? That's 4 pi over 3. If we look at what 4 pi over 3 would be in the first quadrant, we end up with 1 pi over 3, 4 pi over 3. But we're in the third quadrant. The y value is negative, right? So we end up with negative square root of 3 over 2, or negative 0.866. Okay. And then finally, the next angle that we really care about is 3 pi over 2. The sine of 3 pi over 2 is, here's 3 pi over 2, is so we're facing straight down. My y value for that, that's going to be just the negative 1, right? Because it's kind of like 90 degrees. That's the reference angle, I suppose. But we're going to be there at negative 1. Okay. Till we start plotting this. Yeah, let's do that. Okay. So what we're going to do is I'm going to go ahead and draw this guy out here. Right. And we're going to, we have different things. Let me show you a little bit of a trick. One rotation is 2 pi around the circle. Okay. So the way I set up my graph is I know I'm going to go one rotation, which is a little bit artificial. Okay. But it is one rotation around the graph. That's usually what we ask for when we ask people to graph sine and cosine. Okay. So the last point I really care about for my graph is going to be 2 pi. Okay. Now, the way I graph this and doing this, eventually, well, not eventually, you probably are at this point. As far as the rest of your classes go, you're probably the good person at math at this point in your life. And when I was the good person at math, when I was in community college, when I was taking business classes, that was my first major. I get to deal with a lot of people in business, and they were like, "Oh, we have to do a group project." Yeah, like, "Oh, there's going to be graphs in it." Like, we're not good at math. You and I would volunteer. I'm like, "Look, I'll do the really hard part. I'll do the graph. If you guys write the rest of the paper, you can do the easy part. Write the rest of the paper. I'll take on the burden of carrying the graph and dealing with it that way." They're like, "Sure." I'm like, yeah, okay. So one of the things you could do with a graph is you look at the domain, and technically the domain for sine and cosine, they are all real numbers. But since we usually focus on one revolution, we're going to go from 0 to 2 pi. So we go from 0 to like, what's the biggest number that you care about for your graph? Let's go ahead and make that the last number we care so we can draw a pretty picture. Now, half of pi, or half of 2 pi rather, is 1 pi. So it's real easy for people to kind of look at that length and kind of estimate what half of it is. We are good at this as humans. Okay, we're not good at probability, but we are good at thinking about halves. So that's why it's not really a good half. We could probably go a little bit closer, just contradicted myself there. Okay, saying here, humans are good at this, and then I just kind of messed it up. But about half. Okay, I'm trying to get about where that is. Okay. Now, half again, right? What's the distance between 0 and pi? Half of that is pi over 2. Halfway between 1 pi and 2 pi is 3 pi over 2. So look at this. We have 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Or you could take 2 pi plus 2 pi divided by 2 and average them. Okay, that's another way of doing this. 1 pi plus 2 pi is 3 pi over 2. And we have our 4 points. So the 4 points that I'm going to start, that I usually graph with is, well, sine of 0 was 0. Sine of pi over 2 was 1. Okay. Sine of 3 pi over 2 was, we'll say, -1. And then back to 2 pi, right? Sine of 2 pi, we are measuring vertical distances. Sine of 2 pi at pi over 2, that is going to, or 2 pi rather, that's going to be on the axis. That again is 0. Okay. And now we have to come up with some other values here. All right. So again, here's half. Okay. Actually, I'm going to not quite do half there. I know it's not going to look like a half, but I'm trying to make a picture. Okay, so we're going to put half there. So my pi over 6, okay, and when you graph this, you will not be graphing all of these numbers. Please don't do that. You do it once so you can kind of see it, but after that, just like you had parent functions and you had to memorize the shape of functions in college algebra or algebra 2, we do exactly the same thing for trigonometry. There's going to be 6 more graphs that you have to memorize the shapes of. It's not as hard as it seems, but but you have to memorize the shape of these graphs. You didn't have to memorize the reference angles. You do have to memorize the shapes of the graphs. So this is pi over 6, 0.5. Okay. We have pi over 4. We go a little bit further along here, pi over 4. Okay. And that was going to be at 0.7. It's about halfway between 0.5 and 1. Okay. We had pi over 3. Okay, we'll put that over there. We'll move pi over 4 a little bit. We'll put it right here. Pi over 3, that was square root of 3 over 2. That is 0.66. So, or 866. We're going to put that in here, 0.866. So we're going to be up here. I'm going to go ahead and start drawing this thing. We're going to have a line like that. And then we keep going. Okay, so we had our 7 pi. No, we didn't. We had our next one. We had 2 pi over 3. Okay, that was back down to here. Okay, we had our 3 pi over 4. Okay, which is back over here. And then we have our 5 pi over 6, which is down to a half again. Okay, so it's going to come down and look like this. We're going to do one here in Desmos in just a moment. They don't want you to think that these are wagon wheels because they're not hemispheres. Okay, they're not hemicircles. They don't look like that. Okay, my graph is really truncated, it's really shortened in the x-axis. Okay, the y, you could say the y is really elongated. Okay, we're going to show you what a real picture of this looks like so you have a good idea of how to draw the portrait here. Then we went under the graph, right? We had 7 pi over 6. Okay, this was back to pi, right? And then we had 7 pi over 6. It was a little bit negative. It's down here somewhere. Okay, we had 2, 3, 4, 5. We had 5 pi over 4. Okay, that's going to be down here. And then we had 4 pi over 3. That's going to be down here. All the way down to, draw these guys a little bit more accurately. My drawing skills kind of terrible. But down here at 3 pi over 2, we're going to be down here at 1. So it's going to come down something like this. Okay. We're going really slow, which is why my portrait kind of looks crummy. And then we're going to, relive this for the fourth quadrant. So let me go ahead and draw like a little bit easier of a graph. Okay. So when I draw sine, okay, our range goes from -1 to +1. We go from 0. I only want to really graph one revolution. Technically, this keeps going on and on and on. But we have 2 pi, pi over 2, and 3 pi over 2. So we're here, 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 and here. Now, I call these points anchor points because I'm trying to think about, like, if I'm putting little pins up and I've got like a string that I'm going to loop around my graphs, like if I had little push pins, if this was a bulletin board, like I am anchoring my graph to these points. Okay, which is why I call them anchor points, because those are like the points I really care about. This keeps going forever and ever and ever. We can have negative angles. That's fine. This is going to keep going in this direction as well. Okay, so as long as you realize that this waveform goes over and over and over again off to infinity. Okay, so we can, we want to draw like a more accurate thing. You know, it's going to be kind of like your heart, where it's just going to keep going up and down, up and down, up and down like this repeats for hopefully a very, very long time. Hopefully mine does too. And, we could go before birth. We can keep going with this, but I don't want to get into that kind of situation. But before time that happens, but we can do, we're going to have angles going positive and negative, and we're just going to have this waveform go on and on and on. All right. Now, we have some features about the graph. All right. So we have a wavelength, okay, and that is going to go from peak to peak. Okay. So if I go up here, we're going to have a 3 pi over 2. Okay. And then pretty much our one wavelength is equal to 2 pi. All right. That's a wavelength for our standard parent function of pi or sine, cosine 2. It just measures the horizontal, not the vertical. Okay. So we can go ahead and do that. Now we're going to start messing with this graph so that we can go ahead and graph it. So there's different features that we're going to be really caring about for being able to graph. When I go to look at your graph, the first thing I do is I look for your little anchor points, because the instructions on graphing is always going to say graph at least 5 points. Well, I don't want to graph hard points. I want to graph easy points. I am incredibly lazy. I want to graph the easiest points I possibly can. These guys right here, the ones that I showed up with, um, the 0, pi over 2, pi, 3 pi over 2, and 2 pi, those are the easiest points I can graph as far as the sideways go. They're also the easiest points on a cosine graph. Okay. So I don't want to mess with trying to graph, like, technically radians don't have to have a pi in it. You could do a regular X chart with, like, you have an X and a Y and plug in 0, 1, 2, 3. You could do that. I would need a calculator to do that, but we could do it. We could show you right now. It's like, okay, let's go ahead and look at pi's, look at radians. So go ahead and clear this guy out. So we could have, let me make sure I'm in radian mode, because that's always important. We are in radian mode. Excellent. So let's go ahead and click. So I could say the sine of 1. Okay, and it's going to be 0.8 something. Okay, the sine of 2. Okay, and that's going to be in this. That's going to be in the first quadrant. Still, no, it's on the second quadrant. 1 and 2 are both approximately 60 degrees. One's in the first quadrant, one's in the second quadrant. I'll show you what that looks like. Sine of 3. Okay, so if we say sine of 3, we're going to be close to 0, but because 3.14 is pi, so it's going to be a small number. And then we say sine of 4, that's going to be in the second quadrant, or the fourth quadrant rather. No, 1, 2, 3, third quadrant. Okay, sine of 4, that's going to be a negative number. Okay, and we can just keep going around. These do not look like fun numbers that I want to graph. I don't want to graph any of these numbers. They're going to be horrible. So I don't want to graph those. I want to graph easy numbers. So the way I graph this stuff, actually, the way I graph these is to pick the easy values, okay, that we picked up here: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are pretty much the only points I really want to graph for a sine. So that's what we go ahead and do with this. One of the first pieces we're going to learn, like, remember graph transformations from algebra? Of course you do, like it was yesterday. And we are going to have different graph transformations on here. We're going to see what happens. The easiest one to deal with is if we have an A sine theta. Theta is A sine X. Okay, we'll see how X is for a while. Okay, A sine X. Okay, what this thing does on the outside, right? If I say y equals ax squared, what's the a doing to my parabola? Like, well, if a is greater than 0, it's going to stretch it up, right? If a is between 0 and 1, it's going to compress it. It's going to shrink it down. If it's negative, it's going to flip it, okay? This is exactly the same role a has for sine. This does this for almost all the graphs. Okay, so A is called amplitude. Okay, and there's a little bit of a kerfuffle on this one because we don't really deal with negative amplitudes. So the amplitude is actually the absolute value of A. Okay, if it's negative, that's fine, it flips, but we can still consider the amplitude as how high up is the peak from the graph. Okay, and that's what we do first. So that's the idea for amplitude. It's the stretch, it's the vertical stretch or compression of your sine wave or cosine wave. Okay, because cosine is going to work exactly the same way. All right. So cosine, let's go ahead and look at that. Like what cosine is going to look like. We're not going to go through the whole thing here, but cosine x. Cosine of, again, this, you're going to complain, all of your graphs look the same. Like, yeah, I know. That's how I was taught to do it. So this is how I'm teaching you guys how to do it. Okay, this works pretty well. Okay, we're going to use the same 5 anchor points. Cosine of 0 is 1. Cosine of pi over 2. And again, I know I didn't make you memorize the formulas. Go to your calculators, type in cosine of pi of 2, you're going to get 0. Okay? Cosine of pi, you're going to get -1. Cosine of 3 pi over 2. Plug it in your calculator, check it. With enough time plugging in your calculator, you will memorize these things. And it's one of those things like I'm not expecting that you would have all of the angles memorized. You don't have to because you're always going to have the calculator available to you. But you have to be familiar enough with them that you can kind of go check this thing. Okay, we're back up to here, and then back to cosine of 2 pi, we're up here. So cosine of 2 pi, okay, looks something like this. Again, this goes on and on and on forever and ever and ever. Okay, if it had a different amplitude, I would change my -1 to +1. Say I wanted to do, you know, cosine of 3x. Then I'm going to label this as 3. I'm going to label this guy as -3. My amplitude is 3. Okay. Technically, I stretched the graph up, right? But we've already got a perfect graph drawn here. I'm not going to change my graph. I'll change the labeling and make sure that that happens. All right. So that's what we go through and deal with as far as that goes. So let me go ahead and show you what the parent function actually looks like in Desmos. So we'll see about that. It's hard for me to see this. Here you go. Let's move you for a moment. Okay, and let's go ahead and type in Desmos. Okay, of the calculator. Okay, we'll move you back up, I think. Yeah, we'll move you back up. So we'll go ahead and we'll say, okay, y equals sine x, sine x. Okay, I don't want capital, I just want x. Okay, and I'm going to put a little a here. Okay, one of the things I'm going to do is say, I'm going to add a slider for a. All right, and we're going to say, I want a to go from, okay, let's go for a goes from like -3 to +3. Okay, now what I'm going to do here is move you over so I can see this. So look at my sign. Like I said, it's not a wagon wheel. Okay, it's not like two semicircles. My my axes were stretched and shrunk a little bit so I could put everything on as a nice picture, but these are not wagon wheels. Okay, so, and if I go ahead, let's just start at A right now is 1. Okay, but if I start making it go a little bit bigger, notice how the graph is shrinking, it's being stretched and compressed. When it's negative, it flips, just like a reflection is when in college algebra. So that's kind of what we're doing with all of this. Okay, we can speed it up if we want, whatever, but that usually makes people sick, so let's not do that. Okay, 1x. But that's what we could do with this thing. If we change this, okay, you can go play with Desmos a little bit and like, run through this. Yes, that's your homework is to get on this website and start playing with the graph until you understand what the little parameters do. Okay. One of my probability assignments for a lot of times was I had a lot of people who come from other countries and they're not allowed to play cards. If you're religious, your parents may not let you play cards. Your first homework assignment for probability was go play solitaire. on the computer. Go play solitaire with a real deck of cards until you get an understanding of what a deck of cards is. Your homework for this class is, well, you've got sine and cosine. We're going to start adding different features to this to see what happens. Okay. But I think starting adding more features is probably a good subject for the next video. I'm going to stop us here. But before I do, let's go ahead and take a look at y is equal to y equals a cosine x. Okay, so what I'm going to do is I'm going to push you down, and now cosine starts all the way up here. Okay, let's go ahead and put my a back to 1. Okay, we'll go ahead and set a equal to 1 for a little bit. We'll say, yes, I have my slider a equals 1. Where's 1? There you are. Okay, and yes, add slider to a. So you can see, like, on the cosine, you could scroll through this thing and say, oh, yeah, it does go for a long time. Like, yeah, it does. Okay, if we go through, like, oh, 5, it will even label some of the nice points here. Okay, it'll do a lot for us. But, we can go through and do that. So it knows, Desmos knows, like, what the easy problems are. It doesn't know the hard ones so much, but if it's got an easy problem or an easy number, it will label the fact that it's got an easy number for you. All right, so we can go through and do that. But you can see, like, at 0, cosine was 1. So it's 0, 1. And cosine of pi over 2, it's 0. So we can go through and do that. Doesn't look a wagon wheel. It's kind of spread out. That's fine. But we have our a is equal. And again, I'll go ahead and set this thing in motion. You can see how it stretches, how it compresses, how it flips. Okay, and that is your basic idea for what a cosine looks like. Okay, so we'll go ahead and do that a little bit longer. But yes, I wanted to show you what sine and cosine look like, what the amplitude is, because that's the easiest graph transformation we're going to deal with. We will talk about other graph transformations in the next videos. Okay, so with that, I will say thank you very much for watching this video. Start doing homework, start practicing, start figuring out amplitudes, practice graphing these things so you get to know what that shape is and you memorize those shapes. Okay, and I will see you in the next video. Thanks for watching.